that next week is our due date for assignment part 1, okay, on Friday. So each group submit to me one report only lah, not everybody in that group. Okay, just one report for each group. Okay, so it will be soft copy lah to my email. Okay, and also please be note that our test will be on week 6. Okay, so another 2 weeks. Okay, the test will be on week 6. Okay, if I'm not mistaken, it will be on Thursday. Okay, so please check the teaching plan. Okay, already started there. Okay, so your test will be until 3.2, the subtopic, starting from chapter 1 until 3.2. Okay, so what we call, you can start preparing for your test lah. Okay, it will be on week 6. Okay, so we continue from last week. So we start with the exercise 2.1. Okay, so number 2 and also number 4. Okay, so is as a if you already watched the video, okay, the first step before you jump to the solution is to extract the information first. Okay, so chapter 2 and 3, it is very important for you to know, okay, what are the informations given in that question, and then we use that information to solve our problem. Okay, so extract the informations means that you transform the information that you have into mathematical writing. So means that if there is a notation involved there, you have to write into notation the information that you have. Okay, not write in a sentence like that. Okay, so the number 2 here, what is the variable? Variable? Anyone?
Mass of vitamin E.
Number 2.
Number 2.
Number 1, number 2. The variable is?
Length of wood.
Length of wood. Okay, so random number of 100 pieces of wood. So what is 100 here?
N.
Okay, the sample mean of length is a 1.06. So 1.06.
X bar.
Okay. So it is clear that you have word sample. So sample is a sample value lah. Okay, if there is no word sample here, okay, 1.16 still X bar because we have 1.16 after we have sample. Okay, 1.16 after we collect the 100 samples. So it means that 1.06 was calculated from 100 sample. So still X bar, okay. And we have 0.08. So 0.08, that's your
S.
S. Okay, so find a 90% confident interval for the mean length of all wood. Okay, so as I mentioned, if you need to calculate the confident interval, it will be mentioned in that question that you have to calculate the confident interval. Okay, if there is no confident interval, means that there is no use to calculate confident interval. Okay, it must be something else lah that you have to use. Okay, so clear here, you have to calculate the confident interval. So the confident level is 90%. Okay, for mean length of all wood. So all wood here, it is a population because it is all. Okay, so we have mean here, so population mean, then parameter that we need to estimate is a mu. Okay, so that's how we know lah. Okay, we try to estimate mean here. Okay. Okay, so we go to the solution. Okay, so after we extract all the information, Okay, in that question, then you go to the solution. So the first one is to choose which formula that we have. So we have three different formula in this case. Okay, so the first condition that we need to know whether sigma is unknown or known. So in this case, it is unknown or known.
Unknown.
Unknown.
Why it is unknown?
Because it given the sample standard deviation as they give as.
Because they give us, so there is no sigma in that question. Okay, sometimes it could be both. Sometimes you have S, sometimes you have sigma. But in this case, you just have the S. There is no sigma. So that's why we conclude that sigma is unknown. Okay, so the second condition, your N. So we have larger N or small N here.
Larger than 30.
So greater than 30. So we use formula with the Z distribution and S. Okay, you have S in that question, you have N, you have the S bar. So we need to find the value of Z alpha over 2. So confidence level is 90%, so your alpha
0.01.
0.1.
0.1.
0.1. Okay, 10%, 0.1 divided by 2, so 0.0.
0.05.
So we have 1.6.
1.6447.
4.9, right?
9.
Okay. So basically, you just substitute the value in your formula. So what we have for the lower bound? Anyone? Lower bound? $1.0496. Upper bound? 468. Okay. So 1.0732. Should we put unit here? Unit is exist or not? Yes, it is cm. Okay. And then we need to interpret your answer. Okay, so there is two ways to interpret the answer. Okay, either we talk about how confident we are, okay, that mu lies within this range, or we talk about the probability value. Okay, so the first method is a confidently. So we are 90% confident that the population mean of length is between 1.0468 cm and 1.0732 cm. Okay, or we discuss the probability. Okay, because confidence level is a probability of your confidence interval lah. Okay, so the probability, okay, that population mean length of votes is between Okay, so you can choose either one. Okay, whether we discuss the confidently, how confident we are that those that mu lies within that range, or we talk about the probability. Okay, so the next question, what is the width of this confident interval? Okay, so this is A. Okay, this is B. So how do we calculate the width of the confident interval? It is A. How do we calculate?
Upper minus lower.
Upper bound minus lower bound. So your B minus A. Okay, so we have 1.032 minus 1.0468. Other than that, how do we calculate the width? This is the easiest way. How do we calculate the width? Other than that, how do we calculate the width? So width equal to E. How to calculate the E?
Just take the value from the Z alpha over 2 in bracket S over cert n. Just take that value.
The second term of your formula. Okay. So this is how we calculate the E. Use this formula. Okay, the second term of your formula. That's the formula for the E. Okay. You will get similar answer. Okay. Let's say that we change the n here. Okay, instead of 100, let's say that we change to the 50. What happened to the width of your confident interval? It should be increased or it should be decreased? What happened to the width of this confident interval? If we change the sample size, we decrease the sample size. So what happened to the width of confident interval?
Increase.
Increase
Why it is increased?
because error estimation increase.
Because estimation error increase. Okay, so if we change n, we decrease the n, your width will be larger. Why it become larger? Because estimation error increase when we decrease the n. Okay, so should be clear that one. Okay, so number 4. What is the variable for the number 4? What is the variable for the number 4?
Stress test.
Stress test. What do we calculate from the stress test? Sorry, what do we collect from the stress test?
The result.
The result. So your variable is a result of stress test. Variable. Okay, so known to be normally distributed random variable with the mean mu and standard deviation 1.3. So 1.3 here, notation is
Sigma.
sigma. So it is required to have a 95% confidence interval for mu with total width less than 2. Okay, so find the least number of tests that should be carried out to achieve this. Okay, so we collect the data of result of stress test. So the subject is a test here. So we need number of tests. So number of tests here, that's your, if we use notation, what is number of tests here?
N.
N. So we need to calculate the N. Okay. So when we go to the 2.4, okay, you will have two different formula to calculate the N. Okay, the first one by using Ci of the mu and the second one by using CI of this proportion. Okay, so how do we know which formula that we need to use? It is depends on what information that we have. So in this question, okay, the keyword is you have sigma. Okay, you have sigma or you have S. Okay, and also it is clear that here we have 95% of mu. So means that we have to use CI for the mu. CI is a confident interval. Okay, so whenever you have sigma or S, means that we have to use formula from confident interval of mu. Okay, if you have sample proportion, then we have to use the formula for the proportion. Okay, so the formula is n equal to z alpha over 2 sigma divided by e. Okay, if you have the s, then you just substitute the sigma here with the s lah. Okay, so similar. Okay, so you can find the z alpha over 2 here based on confidence level given here. Okay, so we have sigma and then we need to find E. What is your E in this case? How to find the E? E is an estimation error. Where we get the E? It is from? Anyone? From the width of your, from the width. So here we don't have direct information what is the E, okay, but we do have width. Okay, so we have the width. Okay, so we know that width is a 2E, so width less than, okay, less than 2. So width equal to 2E, so means that E equal to 1. Okay, so we just substitute the E here equal to 1. Okay, so you should get what answer? What is the answer here? It should be done right now, the exercise. You will get no one?
6.49.
So 6.4923. 6.4923, but it is a n. So n must be whole number. It cannot be a continuous value. So what we need to do, we have to round up to the next whole number. Okay, so the final answer must be a discrete number. So it is 7. Okay, so the final answer is 7. If you write your answer 6.49 to 3 without round up, then you will lose 1 mark. Okay, because n cannot be the continuous value. It must be discrete number. Okay, any question? Okay, so your quiz 2 is about this subtopic. Okay, so we go to the next subtopic. We have, okay, we have confidence interval for the difference between two population mean. Okay, so two population mean means that the notation is mu1 minus mu2. Okay, we have two different population. Okay, so estimate the confidence interval for the difference between two population mean of independent sample, and then estimate the difference between two population mean of dependent sample. Okay, so we have two different things here. Okay, so you need to know how to distinguish whether we have independent sample or whether we have dependent sample. Okay, sometimes we could misinterpret that one, especially when you have dependent sample. Okay, so usually some students, they cannot see that the question is about dependent variable, sorry, dependent sample. So they will use independent sample, the formula of the independent sample, everything will be 0. Okay, because you misinterpret the question. Okay, so you have to be extra careful here. You have to know how to distinguish Okay, so this term, it will be similar when we go to the chapter 3. We still have similar thing, independent and also dependent sample. But the difference is in chapter 3, we form the hypothesis testing. Okay, so independent sample means that the sample that you have not related to each other. Okay, so means that you will get two set of data from two different set of subject. So subject could be anything. Okay, so the subject here is where you get the data. Okay, so the subject could be anything. It could be people, it could be a thing. Okay, so independent sample means that we get two set of data from two different set of subject. So they are not related to each other. Okay, they are not related to each other. Okay, dependent sample, we still have two set of data, but they come from similar set of subject. Okay, they come from similar set of subject. For example, that okay, just a simple example, you try to see the effect of exercise on the heartbeat of people. Okay, you try to see the effect of the exercise on the heartbeat. Okay, so what you do, okay, you do the experiment on same person. Okay, we have same student. Let's say that student here, student A, B, C, D, E, F. Okay, so what we do, we collect the data of the heartbeat before the exercise. After that, they do maybe 1 hour of the exercise, and then we collect the data of the heartbeat after the exercise. Okay, so you will have two set of data from similar subject. Okay, so means that the data A and the data B, they are related to each other because they are coming from similar subject. Okay, so usually we use dependent sample because we try to reduce, okay, we try to reduce the influence of this characteristic of the subject to the data. Okay, because we have similar subject. When we have independent sample, the characteristic of the subject could influence the data that we collect. Okay, but some research, they prefer to use independent, and some research they prefer to use the dependent. So depends on the research. Okay, there is nothing wrong about that. Okay, so what we do when we have dependent sample, okay, we have two set of data here, but we need to combine these two set of data. So how do we combine? We calculate the data different. Okay, so we calculate the data different. Okay, so so it will be either B minus A or A minus B. Okay, so the rest of the analysis, it will be based on the data difference only. So it means that we will have single data instead of two data for the dependent sample. Okay, because we combine those two data by calculate the data different. So the rest of the analysis, it will be based on that data different only. So notation that we use for the dependent sample, it is mu D. So mu D, D is a data different. So you will find the S bar D, and then you will get the SD. Okay, notation that we use. Okay, so from two data, it will be single data. So the rest of the calculation, it will be based on data different. That's why, okay, the formula that you have for the dependent sample similar to the formula for the single mu. Okay, because single data, it will be like single population, and then but the difference is only on the notation. Okay, so we go first to the independent sample. Okay, so independent sample, it is totally two different population. That's why you have the mu1 and mu2 here. Okay, so that's why you have sigma 1 and sigma 2 here. Okay, two different population. Okay, so we have 5 different formula for this case. Okay, so we have some condition we need to determine in order to choose the formula here. The first condition, whether sigma is known or unknown. Okay, so if known, then we use the first one here. So it will be easy lah. Okay. If unknown, the second condition is equality of population variance. Equality of population variance, not the sample variance. Population variance. Okay, so whether you have equal or whether you have unequal. So equal and unequal. Okay, so this condition, the second condition here, it will be in your question. We can find somewhere in your question this condition, whether we have equal population variance or whether you have unequal population variance. You can find in your question. Okay, if this condition is not in your question, so maybe we have known situation. Okay, or we have the dependent case. Okay, so this situation, this condition will be given in your question until we discuss the chapter 3 later. Okay, so chapter 2 and 3, they are related to each other. Okay, so when we discuss the chapter 3, we will discuss the hypothesis for the ratio of two population variables. Okay, so you will find this later. H0 mu1 equal to the mu2 and H1 mu1 not equal to the mu2. Okay, so in that case, you need to test. Okay, if this condition is not in your question, and then we know that we have unknown case, and it is an independent case with the unknown case. So we need the second condition here to know which formula that we need to use. So you have to test first. So this is hypothesis, chapter 3 later. Okay, so this is how we combine the question from chapter 2 and 3. Okay, similar situation, but you have to perform the hypothesis testing and also confidence interval. So until we discuss this condition will be given in your question. You can find somewhere. Okay, any questions so far? Any question?
So far, no, madam.
So the third condition is to know, the third condition is your sample size. Okay, whether N1, N2 less than 30 or N1, N2 greater than 30. It will be both less than 30 or both greater than 30. Okay, it will not be contradict to each other lah. Okay, so in your statistical table, like what we discussed last week, okay, the formula is there, but it's not complete as what we have here. Okay, that it is not mentioned which one for the known, which one for the unknown, which one for the n greater than 30 and less than 30. Other than that, it is in your statistical table. Okay, so no need to memorize. Okay, so for the case equal population variance here, okay, I just want to mention here that we have the SP. So P is SP is a pool standard deviation. We have additional here. Okay. And then for the case unequal population variance here, for the n less than 30, okay, we have special formula to calculate the degree of freedom of T. Okay, the whole thing here. Okay, the whole thing here just to calculate what is a degree of freedom of T. Okay, so quite tedious formula. Okay, so this value, as we know, degree of freedom of T, in our statistical table, it must be discrete number. So there is no continuous value. So if we get continuous value, for example, 13.99, you have to round down to the whole number. So it will be 13, not 40. Okay, we round down the no value. So it will be 13. Then you can find your statistical table. Okay. Okay, so similar case to the one-sided boundary here. Okay, so what we have here and also in your statistical table, okay, what we have here and also in statistical table, it is a general formula. Okay, we don't use that all the time. Okay, so similar to the common confidence interval just now, the formula that we discussed just now, you still need to know what condition that we have in that question, and then we choose the formula related to those conditions. Okay, it is not always we use this formula. Okay, so after we know identify all the conditions, so what we modify only the alpha. So alpha no need to divide by 2. Okay, so it just alpha. Okay, we go to the number 2 here. Okay, what is the what we call the variable? What is the variable? Variable. Daniel Izudin, what is the variable here? Propellant is where you get the data.
Burning rates.
It is a burning rate. Okay, so burning rate of the two different solid fuel propellant. So two different propellant means that two different population. So means that you have independent case. Okay. So burning rate is your variable here. Okay. It is known that both propellant are normally distributed and have the same population variance. How do we write this statement? Same population variance. How do we write this statement? How do we transform into mathematical writing? You have what here? Anyone? Sigma square 1 equal to the sigma square 2. Okay. So we have two random sample of 26 for each propellant. So means that the what is 26 here? It is? Ada orang jawab? N. Okay, so N for the both propellant. So the sample mean and standard deviation of the burning rate for both propellant are summarized as in table below. Okay. So it is clear that we have sample here, then you will have S bar here, and then you have the S here. Okay, so when you have this statement, you should know that it is unknown case lah. Okay, so that's what we call the clue. Okay, so construct a 90% confidence interval on the difference in population mean for the propellant 2 and propellant 1. Okay, so another keyword here to show that we have independent case. So different in population mean. Okay, when you have different in population mean means that we have independent case. Okay, when we have dependent, okay, the question will be mean different. So it is different. Huh? Okay, another clue that we can use, okay, to distinguish, okay, whether we have independent case or whether we have dependent case. Okay, for the propellant 2 and propellant 1. Okay, so the question already specified that propellant 2 and 1. So means that it will, in your formula, okay, the first population must be propellant 2 and the second population must be propellant 1. Okay, I will show after this. Okay, but okay. Okay, so in this case, sigma is unknown. First condition. Okay, second condition. So we have equal. Okay, the third condition. It is less than 13. Okay. Okay, so we have this condition. So formula that we use, formula with the SP. Okay, so already state here we need propellant 2 first and then propellant 1. So when you write your formula, it will be easy if you write x bar 2 minus x bar 1. Okay, so that we aware that it should be mean for the propellant 2 first and then mean of the propellant 1. Okay, the rest should be okay. Okay, or you can write as usual s bar 1 minus s bar 2, but you have to know that 1 here is a propellant 2 and 2 here is a propellant 1. Okay, you have to follow the question. Okay, but if you have like the question is for the both propellant, okay, let's say that you have general question different in population mean for the both propellant, so it's up to you. Excuse me, you can do propellant 1 minus propellant 2, or you can do propellant 2 minus propellant 1. Both will be accepted. But in this case, we have to follow. It should be propellant 2 minus propellant 1. Okay. So you should get what for the lower boundary? 4.7447. Upper bound 7.4553. 4553. Do we have unit?
Centimeter per second.
And then interpret your answer resulted then as similar as a previous one. Okay, confident interval for the one population mean. Okay, what happens if you have negative confident interval? Can we have negative confident interval here? Can we?
No.
Can. Because mu, in general, it can be from negative infinity to the infinity. When we calculate for the difference, sometimes we could get negative confident interval. Okay, so it is okay to have negative confident interval because in general, mu itself, it can be from negative infinity to the infinity. But when we have negative confident interval, the interpretation must be different, because we need to show the significance of the confident interval even though we have negative confident interval. Okay, so let's say that we have negative. So it could be on lower boundary or it could be on both. Okay, it is okay to have negative confident interval because in general mu can be from negative infinity to the infinity. So how do we comment? Okay, you have example on that. Okay, example this one. Okay, example 2.6. This is how we comment when we have negative infinity. Okay, let's try to do here. So it is about propellant 1 minus propellant 2. So we are confidence level is a 90%. the different population mean of problem 2 and problem 1 is between. So we have to mention lower boundary first without the negative. 4.7447 centimeter per second more by problem 1 and 74553 cm second more by problem 2 compared to each other respectively. Okay, so when we have negative confidence interval, the interpretation will be different because we need to show how the significance of the confidence interval even though we have negative confidence interval. Okay, so negative happen because we calculate for the difference here. Okay, because of the difference. Any questions so far? No? Okay. So we go to the dependent sample. Okay, so as I said, dependent sample, we have two set of data, okay, which is from same subject, okay. So that's why, that's why the formula similar as a confidence interval for the mean, because dependent sample, we combine those two data, okay, by calculate the data different and then the rest of the analysis based on the data different. So now you have single data, okay, that's why the formula similar as mu, okay. The difference is only on notation. So here we have mu d, we have the S bar d, and also we have the SD. So the d here is a data different, okay. Okay, so we go to the exercise. What is the verbal? Verbal. No one is here? Time of what? The retrieval time. Okay, so time to retrieve the image. So from library slide and also computer database. Okay, so the computer database here, that's a digital one. Okay, this is a computer database. Okay, how we know that we have dependent sample in this case? How we know that we have dependent sample in this case? How we know that we have dependent sample? True mean different. Okay, so one of the clue is a true mean different. Okay, so other than that, the most important one is your data here. Okay, so based on the data itself, okay, we should know that the data slide and digital, they are coming from same subject. Okay, here. so it is dependent sample. Okay, let's say that there is no subject here, there is no row. We delete this row. So how do we know that we have dependent sample? Okay, it will be mentioned somewhere in the statement here. Okay, so applied statistic, there is no choice. You have to read the question. Okay, because the information that we need in that question. It is not like you taking ODE, it is not like you are applied calculus or numerical. Okay, mathematics, it is more straightforward question, like integrate this one, this one, this one. Okay, but statistic, you have to read the question. Okay, if this row is not here, then it will be mentioned somewhere in your question here. So an experiment was conducted in which 8 computer medical professionals were timed in both while retrieving an image from library slide and retrieving the same image from computer database. Okay, so means that the time here, they are from similar 8 professionals because we were timed in both. Okay, if you have like 8 different professional, okay, so you might have the independent sample. Okay, so assume that the time retrieving the image is a normally distributed. Find the 95% confidence interval of the true mean difference. As what your friend said, we have keyword here, mean difference between slide and digital time. Okay, so now we know that it is a dependent sample, then we have to calculate the data difference. Okay, so the data different here, it is based which one minus which one depends on that question. So here, slide minus digital. Okay, so slide minus digital. Okay, slide minus digital, so the rest of the calculation based on the data different. Okay, and then choose which formula that we need to use. In this case, do we have sigma? Do we have sigma? No. Okay, so the data here only from 8 professionals, not from all professionals. So it is a sample data. So everything that you calculate for the data different. Okay, after you have the data different, ignore the rest of the data. Don't calculate mean, don't calculate standard deviation from the data slide and digital. Okay, we calculate from data different here. Okay, so from here you calculate X bar D and also you will get SD because sample data. Okay, so there is no sigma. So sigma is unknown. And then we have n equal to 8, so n less than 13. Okay, so use the formula here. What is your answer? Lower bound? What is your answer? Lower bound, 13 eh? Upper bound? Similar to the rest of you? You get similar answer eh? Okay, so it is in, do we have unit here? No. Oh, sorry, second. Okay, so the interpretations are different. Okay, so law, you have to check your answer. You have to check your answer because 2 of your friends get similar. It is different from yours. So check your answer. Must be something wrong, or maybe the value of your S bar and also the value of your S. Okay, so check your answer, maybe the value of S and also S bar. Okay, so interpret the result similar as what we did before lah. Okay, any questions so far? Only same person respond to me. Be ready next week, I will call your name.
Doctor,
Yes. Yes. You can write on chat.
Madam, can bolehkah 2.3.2 question 1 punya interpretation kan guna dalam example 2.8 2.7.
The interpretation.
Ah.
Okay. Means that okay, example 2.7, okay.
Because
Example?
example 2.7 dan example 2.8 kan interpretation lain, tapi boleh tak kita guna dalam example 2.8 je kerana guna yang tadi Dr. ajar 2.3.1 question 2 punya interpretation.
Okay. Yes, I mean when you have what we call positive confidence interval, you can write your interpretation in this form. Okay, so it is similar as the confidence interval of the mu. But what I wrote here, this one right?
Yes.
What I wrote here, in case that you have negative confidence interval. This one. If you have negative confidence interval, you tak boleh pakai macam tadi, tak boleh.
Tapi kalau negatif mesti guna yang
Ini.
Okay.
Yes.
Thank you, madam.
If positive, then similar as what we did for the single mu. Okay, similar to the example here. But when you have negative, we cannot interpret in this form. Okay, tak boleh because we try to make our confidence interval more significant lah, even though it is a negative. Okay, so that's how we do. Okay. So if there is no question, we proceed to the 2.4, okay, for the proportion. So confidence interval for the population proportion, okay. So first you have to know that proportion is for qualitative data, okay, is for qualitative data. So what we have is a number of something, means that you have frequency data, okay. So mean, mu, and also sigma letter, they are for the quantitative data. Okay. Proportion, qualitative data. Okay. For example, that you have the simplest example. Okay, we are talking about, let's say, 100 items, and then we need to identify whether the item that we have here, the item that we produce, defective or not. Okay, so the data will be item 1, yes, no, defective or non-defective. Second data, defective or non-defective. So you have qualitative, okay, but at the end we calculate the number of defective, the number of the non-defective. So the number of what you have is a frequency data. So we go to the proportion. Okay, the parameter that the most suitable parameter for the qualitative is a proportion. We cannot use the mean, we cannot use the variance. Okay, we go to the proportion. So proportion is a probability of something or percentage of something. So that something, your variable. or we call it as a success characteristic in that case. Okay, let's say that we try, the research is about defective item. So your success, the success characteristic is a defective item. Okay, so how do we define based on the question and also based on the information that we have lah? What is our what we call success characteristic? So that's your variable actually. Okay, so population proportion notation that we use is a pi. Okay, so as I mentioned, it's a probability of something or percentage of something. So since it is a probability, so the pi only from 0 to the 1. Okay, it cannot be more than 1, it cannot be less than 0. So similar to the confidence interval here, it is between 0 to the 1 only. Okay, so if you have percentage of something, we need to convert into probability. Okay, we cannot use as it is. Okay, so estimate confidence interval for a population proportion and estimate the sample size. This is the second formula that I discussed before. Okay, the second formula to find the sample size. Okay, so for the formula, okay, so for the proportion, we just have single formula. So means that it should be no problem with the formula when it comes to the proportion. Okay, because we have single formula only. So estimator for the pi is a P. So P is a sample proportion, also in probability. So the value is between 0 to the 1 only. Please take note. Okay, the value of P must be from 0 to the 1 only. So in that question, it will be either they give you the value of P or maybe we give you the value of X. So X is a number of success. So number of success, like I said before, let's say number of defective items. So that's your X. Okay, number of success. Okay, so we have number of defective item 30 out of 50. So 50 is your N. Okay, so it will be either you have P in that question or you have X in that question. If you have X, you can find the P, not X divided by N, that's your P. Okay, so Q here, probability of failure. Okay, so should be no problem with the formula. Okay, so this is the standard deviation of the pi. So the second term here, that's your E. So similar lah. Okay. Okay, and then this is the formula how to find the N. Okay, the formula. So that's why I said in that question you have to know you have sigma or you have P. If you have P, then we use this formula to find the N. Okay, and then let's say that there is no P in that question. We cannot find P, we cannot find X in that question. So we can assume that P equal to the failure. Okay, so P equal to the failure means that 0.5 for each. So we can assume that. Okay, if there is no value of P and X given in that question. Okay, so for the one-sided case, okay, so the formula will be similar. We just have single formula. So you just modify the alpha, no need to divide by 2. Okay, so confidence interval of pi, it is between 0 to the 1 only. Okay, so that's why when you calculate for the one-sided lower bound, okay, automatically upper bound equal to 1. Okay, when we calculate for the upper bound, automatically lower bound equal to 0. Okay, so it is different than mu. Mu we have negative infinity to the infinity, but now we have probability. Okay, so we go to the exercise. Okay, so the cure rate for the standard treatment of the disease is 45%. Dr. Amani has introduced a new treatment which she claims is much better. So she tests the new treatment on 50 patients with the disease and cure 30 of them. Okay, so here first we have percentage of something. So percentage of cure rate. Okay, so automatically you have to know that this is proportion, not the mean, not the variance. So this is proportion. So you are dealing with the proportion. Okay, so what is the variable here? We have variable
Cure.
cure rate. So cure rate. So variable cure rate. Okay, so if we notice that we have standard treatment, we have two different treatment here, and then we have new treatment. Okay, so you can, when we what we call extract the information, then you can write okay, standard, and then we have new treatment. Okay, so we have standard treatment and new treatment. What is 45% here?
S.
Apa? 45%? Okay, so I just said just now, we have percentage of something here, 45% of cure rate. So the cure rate for the standard treatment of the disease is 45%. Okay, so we have 45% of cure rate. So it is proportion. Okay, it is proportion. But here we need to know population proportion or sample proportion. Okay. We have standard treatment and then Dr. Amani introduced the new treatment. So automatically standard treatment, something that already happened before. Okay, because now currently we have new treatment. So standard treatment, something that already happened. Okay, when we have some value from something already happened, past study, past record, it is population value. Okay, it is population value. So what you have here, pi. Okay, 45% here is a pi for the standard treatment. Because standard treatment, something that already happened, currently we are using new treatment. So it is population value. Okay, so 45% is a pi for the standard treatment. Okay, so when you write pi, we know that pi must be from 0 to the 1. So convert into probability, we have 0.45. Okay, so you can check later when you do exercise of proportion, if your value more than 1, something wrong somewhere. Okay, if your confidence interval more than 1, something wrong somewhere. Okay, pi and p, the value should be 0 to 1. I always say to my student, check your value. P and pi should be in between 0 to 1. You get greater than that, something wrong somewhere, or you misinterpret the information. But they still do that. Okay. Okay. Dr. Amani introduced new treatment. She tests the new treatment on 50 patients. What is 50 here?
N.
N. It is N for? So now we have new and treatment. So the 50 here, N for the new or N for the statement? Sorry, statement block, standard.
New.
N for the new treatment. Okay, and cure 30 of them. So 30 is your
X.
X for the new treatment. Okay, find the sampling. The first question already take out from syllabus. You can delete this question. So construct a 99% confidence interval on the cure rate of the disease for the new treatment. Okay, so we need to construct confidence interval on the cure rate. Okay, so how do we know that parameter is pi? First, as I said, we have percentage on something, it is a proportion. And then the cure rate here, information related to cure rate here is a proportion. So that's why we know here that we need to estimate the pi. Okay. For the new treatment, so we need 99% CI of pi for the new. Okay. So we have one formula only. What is P? 0.6. So 30 divided by 50 only. 0.6. Okay. Okay, so 99% alpha, 1% divided by 2, 0.05. So we have for the alpha 2.5758. Okay, so just substitute in your question. So you will get lower bound. Okay. And then interpret, give comment. So how do we comment similar? But when we have proportion, okay, it will be more significant if we transform this confidence interval into percentage. Okay, so we are 99%. This is okay, so it will be more significant lah if we transform into percentage. Okay. Okay, the C question, if no estimation of the sample proportion available, what does it mean? What does it mean? No proportion, no estimation of the sample proportion available. So means that no P. So we assume that P is 0.5. No estimation of sample proportion available. So means that no P. So we assume that P is similar to the failure, which is 0.5. Okay, if this statement is not here, then we use the P that we have before, which is 0.6. So how large is the sample of patient would be if we are 90% confident the estimation error is 5%. So this is E, we have in percentage, so convert into probability, so we have 0.05. Okay, so you have E, you have P, so we need here is a sample of patient, so we need N. So use this formula. This one. So you should get your N. 271. 271. So you will get 270 something, then we round up to the next whole number, so you have 271 questions. Any question? No? Okay, so again, how to say please participate in our class. In just week 4 only. Okay, in just week 4, we have a long journey to go. Okay, so please participate during the class. Okay, be prepared. Next week, if still like this, I will call out your name. Okay, when I ask something, okay, if you still like this, still same person, respond to me, I will call out your name. So please make sure that you are prepared. Okay, I don't mind if your answer is wrong, but I want to see your effort. Okay, so online class, okay, if you like this, I will get bored. Okay, so it is okay for me to not to have class. Okay, I'll be happy to cancel all the class. Okay, but if I cancel all the class, I'm afraid that you cannot catch up what we are discussing. Okay, the whole teaching plan. Okay, that's why I do at least once a week for the class. But if you don't participate, then there is no use for us to do the class. You just watch the video. Okay, so the main reason why I do this virtual class, I want you to I want we discuss what you don't understand. Okay, because you can watch the video. If you just need the answer, you can refer to your module because we have the answer at the back. Okay, if you just want the answer, then there is no use to participate in the virtual class. Okay, so please be more participate on our virtual class because online. Okay, kalau senyap je, kita semua akan bosan. Okay, me too, because okay, this is my third class for this week, so basically I just repeating everything. So can you imagine how bored I am? Okay, so if there is no participation, so there is no use to do the virtual class. Okay, so that's all for today. See you next week. Don't forget the quiz will be on Tuesday. Thank you.
Thank you, madam.
Thank you, madam.